So hello everyone, my name is Zefanya Agung Mangempis. So today I'm gonna teach you how to use SmartPLS on MacBook. So as you can see, I already gathered some data from the random people about investing. So independent variable that I use is from personality trait. This is a form. This one from A to E, all of it, the question. And for mediation, I use from AI usage, this one, 1 until 7. So for the dependent variable, I use anchoring bias. It's from this one. So what are we gonna do next is open SmartPLS, make a project and import the data. By the way, I already divided into independent variable, mediation, and dependent. So here's the 100 data. I mean 99 data, including the variable names. So what we're gonna do is save as and import it as a CSV, comma separated value. So after that, we're gonna click on this and import the data here on SmartPLS, and we're gonna rename it ALP. Okay, after this we got something like indicator correlation, but it's still loading. So what are we gonna do next is create your model. We're gonna rename it ALP model. So what are we gonna do next is input all of this. So what are we gonna do next is to connect this data. Okay, so we're gonna rename it one by one. So so click right, rename. Okay, we're already rename it all. So what we're gonna do next is to calculate the PLS algorithm. We just can basically use 300 for maximum iteration and stop iteration Citrion at 7. Okay, calculate. Okay, so what are we gonna do next is to check the outer loadings. So as you can see, the data has shown that the A variable B and C is not valid. It is because it is below 0.7. So vice versa. For example, this, it is not valid, but this, it is valid. So we're gonna remove A, B, and C. We're gonna use D and E only. Okay, so we're gonna calculate again. Okay, so the data shown that all of it are valid. Is it it's okay to just put dependent to dependent variable. It is fine as long as the data is valid. So after this, what we're gonna do next is to go to latent variable and choose this. After this, we're gonna see about the correlation between the variable. If it's 0.4, it means weak correlation. If it's between 0.4 and 0.6, it means moderate correlation. If it's 0.6, it means strong correlation. So we're gonna move to the next step, is to construct reliability and validity. So based on Chrome Alpha, the data that needs to be reliable is more than or same as 0.7. The same goes to RHOA. So as we can see in the matrix, agreeableness and anchoring bias is not valid or it's not reliable. So what are we gonna do next is to check the data are valid or not using discriminant validity here on heterotrait, monotrait. So as we can see here, the data is shown that below 0.9. That means all of the data are valid or good based on this. So after checking this, what are we gonna do next is to check the collinearity statistic using fifth. So as you can see here, it's to determine whether they are multicollinearity problem or not using this inner free values. So after checking this, what we're gonna do is to conduct the bootstrapping. This is to determine the data are significant or not. So we can start calculation. So as you can see here, the agreeableness and AI usage and agreeableness and anchoring bias is significant, as you can see here. So after this, we're gonna calculate about the specific indirect effect, which means that the agreeableness mediation of AI usage to anchoring bias is not significant. The same goes for this. So what are we gonna do next is to check the PLS algorithm again. And if you want to find the percentage, go to S square. And for the R square, there's 12.5% only that the AI usage can be explained by the independent variable. And the same goes for the anchoring bias, which is 22.2%. So after we know the percentage, we're gonna move to F square. So from this, we can conclude that they have the small effect, agreeableness between AI usage, agreeableness between anchoring bias, and so on. So after this, we're gonna go back to the model, and from blindfolding, we're gonna know about the Q square. Okay, we're gonna start the calculation with omission distance 7 omission distance. So based on this data, we can conclude that AI usage and anchoring bias have a small predictive on the variable